So I'm using 8 cores at the same time to train my model. And a lot of times when your model is more complex, I think it's here. Yeah, there we go, it's done. It was quick, it just takes 24 seconds to run it. When your data is really huge, let's say you have millions of images, or you have, I don't know, 10 terabytes or maybe even more, 1 petabyte of data, and you want to do this, then you appreciate this parallel computation in Spark a lot more, because you see how we can actually scale. In your machines, you're just bounded by the amount of the memory you have on your machine, versus here, you're actually using, again, cloud computation, and you can scale. If you need 4 machines, you can get 4 machines. If you want 10 machines, you can use 10 machines. And this algorithm still runs. You can even speed it up. If I do this, you can use all the threads on CPUs and run this. Just remember, this was 24 seconds to train my model, to predict that price on the data set that I have. So if I use parallelism, which I'm not gonna go through the detail of it, this is going to use multiple thread and even inside the core, it actually used parallel computation and parallel training. And look at this, took 14 seconds to run it. I can even speed it up. Again, this comes with experience. If you work with the Spark and if you understand like how the big data works in the Spark, then you can actually do a lot of optimization here. So this took 7 seconds to run. And then at the end, I'm getting my model. So this tells you how much error you had. So the model is not great. So again, we have a bunch of metrics in data science and machine learning. So pretty much you can do, this is what just end-to-end, I call it end-to-end machine learning demo, that you get your data, you clean your data, you come up with your model, and then you actually run it and your model is trained. You see this model that we get at the end, CB model, this is the model that a lot of people, when they talk about machine learning model, this is the model that is already trained. It means it has learned your data. Okay, recipe for successful industry experience. I'm gonna finish it in probably like next 4 minutes. Communication skill, I'm sure other speakers have talked about this. It matters. I cannot emphasize this more. I needed to really focus on communication skills because it requires differently, not just because you're doing interview, but because you are going from academia and you're actually going into the industry, and people speak with different language and not everyone is technical. So you should have a really good communication skills to talk to people, non-technical people, and you can actually convey your message. Network matter as well. Make sure you do networking. If I could go back in my undergrad, I would do more networking with different people, not necessarily just your own department, from other departments as well. So you get to know other people, other perspectives. Shift from algorithm to solution. This is the most important shift I needed to do. I'm really technically inclined to do a lot of like, look at the algorithms, read all of these papers, see how it works and so on. But when you get into industry, a lot of people look at the solutions. So they really don't care about your algorithm. They want to solve their problem because the money a lot of times is involved in that problem they have. So they need you to solve their solution. They really don't care about that algorithm. So when you communicate with them, they're all talking about their problem, and you should always talk about the solution, not the algorithm. 80-20 rule, I always have that as well. If you're going to an industry, 80% is good enough. There is no, I call it illusion of perfection. There is no perfect things in data science. There is no perfect solution in industry. So 80% is good, and then you can iterate through those solutions. Relationship matters. So I'm not talking about boyfriend, girlfriend here. So relationship with different people in the company. So that matters so much. So you actually make your network. It's kind of connected to number 2. Humbleness. Yes, that's one thing I really take it seriously. Because the technical people have tendency of really focusing on, again, algorithm, measuring everything by that, but you need some humbleness and attitude, good attitude towards, again, industry in terms of, again, I cannot emphasize, you want to solve the solution is not about algorithm industry. Yes, you use those algorithms, but at the end of the day, you want to solve that solution. People looking for some people that they have good attitude and they're humble so they can talk about their problem with. Passion versus habit. This is one thing I really disagree with Steve Jobs. So passion is awesome, but rare. If you're lucky, probably you find it at early age, very early age, you start following your passion. If not, probably you're like most people, don't panic here. So I would say it's probably not that much time to keep searching for all of them. So I always have this recipe. I came to this probably a few years ago. Write down 10 things you really want to achieve in life. Doesn't matter if it's financially, academically, whatever it is. Just pick top 3. That's going to be in your mind and focus on the first one. Design an action plan. Stick to it. It's very hard to actually develop that habit of sticking to something, and be flexible. And during the time, have fun. And based on my experience, again, this is I call it my soapbox. It's like my ideology through this. Excellence is an outcome of good habits. So if you constantly doing something and actually getting the feedback, I'm going back to control theory, you get the feedback, you correct your action, and you really focus on small things, those small things make a big picture. And at the end, you might actually turn your habit to passion. Some books, technical books, definitely if you want to, that's hands down, I said the first top 2, if you want to get into data science, an introduction to statistical learning with application in R, the elements of statistical learning. By no means I'm saying that all of the books that listed here is exhaustive. The list is not, but the first 2, I would say, helped me so much. And any books in financial econometrics, if you want to know about time series, I would say pick up any books in financial econometrics. And if you want to know about the conferences, we have KDD, ICML, and NeurIPS. So people say NEPS. So NeurIPS conferences, these are the really, really important conferences in machine learning. A lot of times, I think all the times, all of their journals or preceding of the conference is available. So if you go online, KDD, probably you can find all the papers in 2018 and read about those. Non-technical books, the 7 Habits of Highly Effective People. I really suggest that. Start with why. That's famous, again, why you want to do something. Another one, The Subtle Art of Not Giving Ebb. That's a good one. It tells you to shift your focus. That's about not taking things really seriously and actually how you can move on from one problem to another without sticking just to past. The other one is, I would call it semi-technical, but it's not really technical, The Signal and Noise. Highly recommended. It's 500 pages, but it's highly recommended. Why so many predictions fail, but some don't. And it's amazing. It's written by someone who understands the business and is a practitioner. Yes, highly recommended here. So I think I'm over time. Probably I talked about more than 15 minutes. But yeah, thank you. So we can get to QA.
Wow, that was a good presentation. Wow, thank you very much. Yeah. So can you stop sharing your desktop now?
Yes. There we go.
We can go back to the our moderators. Oh, not me. Not me. I'm not going to be the first one asking questions. So
Sure.
we have Emma and Bill, and they're going to start asking you questions. So yeah,
Sure.
Let's go. Or somebody else, in fact, in the audience. Here we go.
So when you were talking about the machine learning model, was it the CD model or the CD model?
Yeah.
How was that formulated?
So in the back end, there's something called decision tree, right? So decision tree, you can think about it like decision. You start from the top, and then based on those features that I showed you, based on those variables, it starts splitting. It makes decision. So let's say it picks the is superhost true or false, right? So you have 2 options for that. It kind of pick a split, and then it goes down the tree. And then in the next one, again, you have a bunch of other variables to consider. It picks the one that it gives you, in some sense, I don't want to go through the very detail of it, but it's called information gain. So the more you go through down the tree, the leaves getting more pure. So you want to split your data. Let's say you want to predict if someone's gonna default on the loan or not. So it picks those variables that are really important and split on those specific values of those variables, so that all of the lips, it becomes pure. So in other words, you those that they have defaulted and those that they have not defaulted have been separated very well as you go down the tree. Does that make sense?
Yeah, it does. Thank you.
Yeah, and then you have that cross-validation is another technique that I use with decision tree, because you don't know how far you want to go down the tree. The more you go down, the purer it gets, but at the same time, you might not be generalize your model. So there is a technique called cross-validation, but to pick the best parameters. So you don't know how far you want to go down. That cross-validation helps you to pick how far you want to go down, pretty much. That's what's called cross-validation.
Gotcha. Sweet. Thank you.
Yeah, you're welcome.
Is your mic on?
I was wondering if there was. Oh, can you hear me?
Yes, I can.
Okay. I was wondering if there was any specific class that helped you the most in your undergraduate or graduate studies.
Undergraduate, I would say definitely, I know it's not related, but it helped me to do a lot of good problem solving. I would say real analysis. It was one of my favorite that I did. And non-linear dynamics, I would say there are two of them. It really, really helped me. And in grad studies, I have good courses, like very good courses. I would say computational finance was one of them that really opened up my eyes to a lot of other things that I was not aware of. And stochastic processes. So there are 4 courses you want to say: undergrad, nonlinear dynamics, real analysis; undergrad, computational finance, and stochastic processes.
Okay, thank you.
You're welcome.
Oh, yeah.
Go ahead.
I thought you guys gonna ask a lot of questions from me because
Yeah, there's one coming.
I feel that I went through this material so fast, but I'm hoping that I was not speaking too fast. So that's I'm hoping that.
You're all good.
Okay.
So I have a question about getting in the industry. Would you say, let's say I wasn't going the grad school route, what would you say would be my best way to get into industry?
It really depends. That's a very good question. There is no necessity to go to grad school to go to industry. I would say actually a lot of people I work with right now in San Francisco in our office here. I live in Dallas, by the way, but I came here for a visit. A lot of people here, actually they do development. A lot of them just have a bachelor's degree. You don't have to go to grad school. And I would say if you want, it depends what you want to do. Again, it comes back to what really that top 3 you want to do. If you want to get into tech industry, I would say definitely work on programming skill sets. That is really, really important if you want to get to tech. And also there are 2 things that I always say. One of them is, again, I'm going to computer science, but data structure and algorithms. So there are these 3 topics really important. They measure you based on that. They're not looking at your degree or you have a grad degree or so on. As long as you can program, you can be articulated, and you can actually convey, and you can speak, you have a good communication skills. I think that's the way to go to industry.
So when you say programming and then data structuring, would you say certain programming languages play the biggest part? Like which ones would you?
It depends. Like I would say definitely learn one object-oriented programming language. For example, I started with C++. A lot of people don't want to deal with memory management. They start with Java. Whatever you use, just at least learn one of those languages like Java or C++. And then that if you learn it correctly and you learn all of those techniques or programming skill set, then I would say Python matters so much as well. If you want to get into data science, not necessary for all of the things, but I would say pick one of your object-oriented programming language and pick Python if I want to pick 2 languages.
Gotcha. Would you say SQL plays a big part in like the everyday life?
That is correct, yes. If you are doing data science, you definitely knowing SQL matters so much. If you want to do a business analyst, like in American Airlines, I've worked with a lot of business analysts, you need to know SQL as well. So that's part of it as well, yes. Again, depends on what you want to do, but if you learn SQL, one of those query languages, one of the object-oriented language, and Python, that's you pretty set.
Gotcha. Thank you.
You're welcome.
Just to follow up, Amir. So when did you get exposed to Python? And this is my first question. The second question is like, did you get any specific training at the company that you did not know before, technical wise,
Good question.
but you just learned when you were in Databricks?